Hello, everyone. Welcome to today's live broadcast, leveraging the power of recipe-driven execution and standardization. I'm Megan Manzano, and I'll be your moderator for today's event. We are pleased to bring you this webcast presented by Pharmaceutical Technology and sponsored by Siemens Digital Industries. I would like to share a statement from our sponsor. Siemens Digital Industries is an innovation leader in automation and digitalization, driving digital transformation in the process and discrete industries by providing companies of all sizes with an end-to-end set of products, solutions, and services to integrate and digitalize the entire value chain. DI's unique portfolio is optimized for the specific needs of each industry to support customers in achieving greater productivity and flexibility. Siemens Digital Industries has its global headquarters in Nuremberg, Germany, and has around 75,000 employees internationally. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found at the bottom of the video player. You can enlarge the slide window by clicking on the small icon in the bottom right corner of the media player. The slides will advance automatically during the event. If you have any technical problems viewing or hearing this presentation, please click on the question mark help widget in the top right of your presentation window. I would now like to introduce today's speakers, Matt Casey, Christian Corner, and Dashi Radharanatnam. As head of execution systems at CSL Behring, Matt Casey leads teams responsible for operational support of the manufacturing systems utilized in the core value streams such as blood plasma fractionation, bulk processing and purification, parenteral fill and finish, and final packaging. Matt has 20 years of industry experience across a variety of disciplines. Christian Corner leads the life sciences businesses for Siemens in the US. He joined Siemens straight out of university, where his first task was implementing and commissioning integrated DCS and MES technologies into highly automated pharmaceutical production plants. He eventually pursued a role as a corporate account manager, where he led the collaboration with one of Siemens' key strategic partners. Dashi Radharanatnam is a seasoned automation engineer with over 15 years of industry experience, demonstrating a diverse range of skills and knowledge cultivated across 4 continents. Her career is distinguished by a proven track record, highlighted by her pivotal role as lead engineer in spearheading multiple simulation projects at CSL. Thank you all so much for joining us today. Please get us started.
Me unmute there. Thank you very much, Megan, for the intro. I'm going to share my screen here, so just give me a minute to pull up the slides. And there we go. Okay, so yeah, thank you again, Megan, for the introduction. We're going to talk today a little bit about our recipe-driven execution platform. We're going to hit some subjects around standardization and as well as simulation as well. So with that, I will jump into the slides here. And Megan went through biographies, so there's some pictures of myself, Christian, and Dashi, and we're from CSL, Siemens, and the Mascota teams. Okay, so what's our agenda for today? We're gonna have a brief introduction of CSL, and we'll go through our various business units and our key drivers. We're going to move into our technology vision and our key business objectives and our key business drivers. We're going to talk a little bit about a collaboration that we have with CSL, Siemens, and Mascota, and some of the joint projects that we work together on. We're then going to move into a more of a technical focused topic, a technology deep dive into recipe-driven execution, standardization. We'll explain what that means in the landscape of CSL, and also give a few examples of some case studies that we've had. We'll then touch on some realized benefits as well as what we're looking to work towards in the future. And then we'll hand over to Dashi. She's going to talk a little bit about a case study relative to digital twin for RDE that we had used at CSL as well. Okay, so first we'll jump into the CSL introduction. So the CSL group is made up of 3 core business units. So one, CSL Behring is focused on blood plasma products, and a lot of the case studies that we'll be talking through today are relative to projects and rollout within the CSL Behring business unit. CSL Seqirus is focused on vaccines, primarily influenza vaccines, and then CSL Vifor is focused on iron deficiency products. So these three business units make up the CSL group together, and our focus is really providing products to our patients, and we do that through our group of employees, over 32,000 people across the globe. This next slide gives a view, high-level view of our manufacturing network. And so these are our production plants that we have across the globe. So this is Behring, Seqirus, and Vifor, and we'll be covering a couple projects within US as well as Switzerland and Australia as well. But this gives a view of our landscape, and so we'll share some of the importance of standardization and how we can reuse configuration across the manufacturing network. Okay, so the next section, we'll talk a little bit about our technology vision, some of our key business drivers, and we'll give a view into the CSL corporate strategy and what we do within Execution Systems to execute against that strategy. So this thing that you would find on the CSL Group homepage. This is our overall corporate strategy, and these are our core pillars around patient focus, innovation, efficiency and reliable supply, sustainable growth, and digital transformation. And so our corporate strategy is aligned to all of these pillars. We're going to focus in on a few, namely innovation, reliable supply, digital transformation, and what enable what we do within Execution Systems and the team to work toward to enable these. So one key topic is around fulfilling our promise to our patients. We want to ensure that we can provide efficient and reliable supply to meet the needs that we have there. As a team, we want to understand innovative industry trends, and so we want to know what is out there in the industry. We want to have leverage best practices to support the business and manufacturing and CSL Group in general for effective and efficient manufacturing technologies. We also want to leverage digital technology to allow us to empower a modern organization that will embrace innovations in the area of automation, again, manufacturing technology and data availability. So the next slide is some diving in a bit deeper. These are some key business drivers and technology objectives that we have, and again some more specifics about how we can deliver against it. So one topic is around speed to patient, and so from an Execution Systems perspective, we want to ensure that we have end-to-end globally aligned manufacturing execution systems designs that can allow for expedited implementation of new processes and projects, and also ensure that we can have efficient globally aligned process changes. We also want to have efficient and reliable supply, so we want to improve the overall, we want to have good, strong robustness around the system. We want reliability via a simpler automation design. And we want to be able to leverage and reuse standard configuration to help us roll out changes and more quickly. And then from a cost of ownership perspective, so we want to ensure that we can have leverage standardization to have a lower cost implementation for projects. We want to be able to reuse standard configuration and again be able to make changes to that standard configuration to roll out quickly and easily. And we want our systems to be globally aligned to this execution model. So how do we do this, right? So we have a few enablers within, again, within the team that we're focused on. One we're going to talk a little bit about is recipe-driven execution and the implementation of that. And we'll go into technically what that looks like and what the infrastructure and architecture and design of recipe-driven execution looks like. But from a high-level perspective, it's really a standardized and simplified philosophy and a well-integrated stack with our enterprise systems and other systems that we have on the floor. This implementation, we want to be aligned to industry best practices, particularly ISA 88 principles and standards. And with that, we want to ensure that we have our recipe design that's really aligned throughout the organization. So within process engineering, R&D, quality, manufacturing, we want process documentation and our manufacturing processes, parameter criticality aligned to the principles within S88. Which also aligns to the recipes that we have running on the floor. And with that, we want our manufacturing recipes to be aligned to common technical documents. So really, any process documentation that feeds into our recipes, we want to make sure we have alignment there. And then lastly, that will support us for data historization platforms and ensuring that we have consistent data contextualization practices across the processes that we run. Okay, so the next section I'm going to hand over to Christian. He's going to talk a little bit about the collaboration across teams here, CSL, Siemens, and Moscato.
Right, was that we clearly spelled out what the expected benefits were that we were hoping to get out of this collaboration. And the two key expectations in terms of benefits were around time savings and cost savings. And that picture here in the middle is supposed to show you a high-level summary of what we mean by that. And what we've done here is we have compared the project lead times for projects that we were delivering for automation and MES platforms in a traditional setup versus via in a standardized setup. So if you look at the traditional setup, first of all, on average, we could say that the time taken to deliver each one of those platforms across the various projects within the CSL supply chain would cost on average the same and roughly take about the same time. We would always go through the classical V model iteration of designing the software, implementing the software, testing it, and delivering it to the site. Whereas in the standardized model, our expectation was, our ambition was to develop a global library that would host reusable objects for automation and for DCS that would design in a such manner to be applicable towards multiple different process scenarios, with the intent then that we could use those objects again and again throughout the various projects or sites. And the reuse of those objects is in essence how we were expecting time and cost savings in essence. And that applies both on the CapEx side of things, so on the upfront delivery, but then as Matt also mentioned, around the operational cost side of things to be able to maintain those. A couple of other expected benefits that we were hoping to get out of the collaboration was in regards to reduction in lead time for process enhancements. So think, for instance, about new features that were developed over time, or even entirely new process kits that were aimed at improving efficiencies further on, and those needed to be integrated into those platforms, right? Being able to roll those process enhancements out more effectively over the supply chain was a clear ambition. And then lastly, we have the topic here around execution system lifecycle support, which is a reference towards being able to maintain those objects and those platforms over the life cycle. And then lastly here, the idea of a global harmonization of value streams, which is in essence a harmonization on the operational philosophy across the various plant types. Now, how would we go about achieving those benefits? Well, on the one hand side, it is the development around the aforementioned core library that would host, again, reusable objects for automation, for MES that could be used again and again and again across all the various projects or sites. And then secondly, we would look at deploying a centralized project team that would follow the CSL journey across the globe. Yeah, switch it a little bit. Yeah, so this slide here is supposed to give you a high-level view on some of the challenges that CSL was facing prior to their standardization journey. I think the core theme here is also the title of the slide, decentralization. If we were to look at the CSL supply chain, looking at fractionation, bulk processing, or full finishing, we would see that the individual plant types even though they were manufacturing the same or similar product, they were quite different if you were to look at them from a technology landscape perspective. I'll give a few examples here. So for instance, some sites would already have an MES platform in place to do paperless manufacturing. Other sites wouldn't. On the DCS layer, we would see multiple different platforms being used, and also the level of integration between the various platforms was different. And all of those aspects taken into consideration would have a certain negative impact towards the business. And I'm just going to name a few of those bullets that you see here in the bottom hand side of the slide, such as inconsistent interfaces and data transactions. What we were also seeing was a disjointed DCS MES user experience, which meant that the plant operators would need to interface multiple different screens and in order to drive their manufacturing process. We were seeing that at that time there was no or minimal levels of standardization in place, and overall you could say that the production network was comprised of multiple and diverging site-based business processes. I think the core message here on this slide would be that CSL had the endeavor of rolling out those platforms more effectively across various projects, and at the time the cost was quite simply too high, both on the CapEx side, so the original delivery of those platforms, but then also on the OpEx side of things in order to be able to maintain them. And that goes in line with then the last bullet here on this slide, which is no formal system lifecycle monitoring in place at the time. So if we, right, I can do that. Okay, so this slide here is supposed to give a high-level summary on how standardization exactly creates business value and what the 4 fundamental key pillars are for success. And we've tried to summarize that by means of a pyramid diagram here, where all the way on the top, we have the business value. Now, the business value we've already addressed in length in the previous sections, but in summary, simpler design, lower cost of ownership, and most importantly, the idea of speed to patient. So CSL manufactures medicines for rare diseases, and there's a lot of patients out there that need those medicines. And our primary goal was here to bring those medicines to the market faster, and doing that via a lower cost of ownership. Now, in order to achieve those business values, we needed technology. Matt is going to, in the later section, on the next section, deep dive further into the technology. But at this point, key message here is that we were looking at developing standardized objects that could be applicable to, that would be applicable to various different process scenarios, and the reusability of those objects were absolutely key from a technology perspective. Having a life cycle in place that we would be able to maintain the technology over the runtime, and then doing all of that by means of a data-centric engineering design. And then lastly, we cannot bring technology to life without people. So people really form the basis of all of this, where we needed people that were, I would say, thinking globally and acting locally. And what I mean by that is that we needed people here on board that were both part of the front end conceptual design phase, where we were really looking to figure out how the standardization was supposed to work. RDE, Matt is going to talk about that. What should that look like exactly? But then also later on, once we were rolling out those standards across the supply chain, to be part of that journey and support the local sites, which is then where we have developed or deployed agile project delivery teams that would follow that journey. And then lastly, also what we have done, of course, here is to set up an executive sponsorship program, which is in essence the idea of our C-level management meeting in a regular cadence in order to discuss potential roadblocks or any kind of challenges that may pop up along the road, and then help us in our joint vision. Those 3 pillars here really form the fundament for a successful collaboration. And with that, I'll hand it back over to Matt, who's going to further deep dive into the technology aspect of it.
Perfect. Thanks, Christian. And I'm gonna flip back to that prior slide, because I think a lot of people on the call can very well relate to the foundation of having strong project teams, strong people working on implementations, in pharma and in the industry. And the technology is important, but in some cases, it doesn't matter how good the technology is if you don't have the right foundation of people working on it. So that foundation of the people with the technology can really add a lot of value to the business when folks are working together to deliver that. So I like that that kind of layered approach and foundational approach to the business drivers, business value there. So now we'll get into the fun stuff. So we're going to talk a little bit about the technology deep dive. We're gonna explain a bit what recipe execution is. I think in an hour we can't cover everything, and we'll certainly open to follow-up conversations or any questions that people may have on what RDE, recipe-driven execution, looks like in CSL. So with that, let's jump into it. So what is recipe-driven execution platform? So recipe-driven execution, this is our program name or our term within CSL, and it's referring to our design for our manufacturing execution system. So it's our design of our DCS, MES systems, interfaces with enterprise systems, and our data historian. All of those make up our recipe-driven execution platform. The primary component or fundamental component to RDE is to use a model where the DCS system is the primary batch engine. So our goal is to move away from parallel recipes of an MES or DCS system or competing for process activities. The goal of recipe-driven execution is to work where the DCS system is our primary batch engine. So any sequencing, and we'll show you what this looks like, but any sequencing of process activities is going to really be triggered again from the DCS system. And if there's things that need to occur with an enterprise system, it will call out to MES to trigger those. That platform is utilizing standard configuration modules within DCS, MES, and to a certain extent, even our enterprise integration. And those Lego blocks or those standard configuration modules are reused across the organization. The next component is around the interfaces. So as I mentioned, we have a standard mapping of interface transactions with our enterprise systems, particularly with our ERP, LIMS, document management systems, and we want to ensure we're leveraging that the same method of interfacing again with our enterprise systems. The next component is around our process data historian platform, and so coupled with our recipe-driven execution program, we had a program to also roll out a standard process data historian platform across all of the manufacturing sites. And the goal here is to enable consistent approach to how we historize data, ensure that we have data historization that includes not only continuous data, but also batch context data. And since our primary engine is the DCS system, we can have consistency around that batch contextualization. The next component is around the batch release process, and specifically with review by exception. So the goal of the platform is to enable review by exception and basically an exception-based review process. So really focus on criticality, focus on your batch review on items that could deviate from the process. And then the last component, we'll say that this platform or the execution of this platform that we're talking through here is with Siemens, but within CSL, our goal is really to have this be platform agnostic. So recipe-driven execution is a execution systems design that can work within Siemens, but also has to work within other applications that we have in our network as well. With that, we'll move over to a bit of a deep dive into what this looks like. This is our view of the infrastructure architecture of the system. So I'm going to start really in the center. And so the DCS system is large and in the center of this view, because this is our primary batch engine, our primary process engine. So typical DCS, this is going to manage our equipment control. All our recipe parameterization will be sourced from here. And as we need to call out to do different activities, the DCS will create trigger points via MES to interface with LIMS for things like sample collection and sample results. Interface with QMS systems for deviation tracking and really traceability of deviation management from our QMS systems to back to our executed batch recipe, to ERP for things like inventory management, material quality status, those types of things. Also to our QMS system for batch documentation and SOPs and procedures. And then on the right side, we have our process data view. So MES, DCS, utility systems intended to go to our process data historian, which is our long-term historian and process data archival system. And then there's linkage from that and other systems to some of our corporate data warehouses. And then the last thing I'll mention on this slide is the batch release. So we have a green dashed line that shows the core inputs into the review by exception, really coming from the completion of the LIMS sample plan, the status check of any deviations that may be raised during the process, the linkage with our ERP systems as far as material declaration, and then of course the batch record execution from MES and DCS. So that's a high-level view of the architecture. The next slide is to walk through again a high-level view of the workflow of a recipe-driven execution batch. And so we're showing our primary systems. So again, enterprise systems are going to be linked to document management systems, LIMS, ERP. Those traditional enterprise systems. We then have our MES system and our DCS system. So when we kick off a batch, this really will be triggered from our enterprise system, which would send communication down to MES. And so the trigger point comes from SAP that would create or comes from our ERP system that would create a sample plan within our LIMS system and also trigger the MES order. From the MES order, that's going to create the DCS batch, and again, the DCS system is going to be our primary batch engine. So from there, all of our sequence of operations would be triggered. So as an example, we would kick off a temperature control. This would be a standardized building block, Lego block for temperature control running on equipment. That's going to be isolated to the DCS system. Any of the parameterization would be within the DCS recipe. Once that temperature control is established, as an example, we may go into a sample operation. That sample operation has some interactions with MES and enterprise systems. So we would trigger that sample phase from the DCS system, which would trigger our MES function to call out to our enterprise system. And then we would have the sample traceability as well as sample results through LIMS. And that's not shown as bidirectional, but that is also a bidirectional transfer if we need to use the sample data to make some decisioning on the floor. So again, RDE means that the automation recipe is really going to drive the entire process, and it's going to trigger any of those MES or enterprise system events that may come up. So following from a sample, as an example, we have operator messages, and so that would interact with MES as well to trigger some of the operator prompts. We have an example of a material consumption or material declaration, again, where we would trigger inventory messages with MES and our enterprise systems, and then finally end the batch and go through the review by exception process. And the last piece I'll comment on is as the batch is executing, we have our standard around data availability from our process historian. Currently our DCS systems are connected to our process data historian, and one of our future implementation is to bring that MES data into to the historian as well. And this gives a view of all of the synchronization with the process historian too. So that gives a view of the architecture of the system, the process flow, and we can certainly take some questions relative to that. From that, I'm going to hand it back over to Christian. We're going to talk a little bit about some of the library principles within CSL and how how the library can be started, but then also evolved over time. So with that, I'll hand over back over to Christian.
Good. So what we've now learned from Matt, in essence, was that RDE is, in essence, the idea of building those reusable objects, as you have just seen in that slide before, and all of those objects and functionalities, in essence, being driven and executed via a common batch recipe. The question that may now ultimately pop up in your minds is, well, how do we make those objects available to the respective sites or plants that want to leverage the power of standardization? And it is then where the idea of a global library comes into play. A global library, you could think of it in the following manner, that lives and resides in the cloud, that would host all of those individual objects for DCS, objects for MES, and objects for enterprise, all associated with their own life cycle in place. And let's take an example. Let's take an example now where Project A, for instance, would want to leverage standardization. What they would do, in essence, they would log on to the global library and they would look at all the features that are embedded within that library and look at those functionalities that are applicable to them. And then, in essence, download that feature set. And here exactly you can see where the true benefits lie, because those objects are designed and implemented once, and by leveraging those exact same instances is exactly how we would go about accelerating the time and reducing costs ultimately. Now, as with any standardization activity, it is a journey that evolves over time. So think about a new feature that is being developed later on, or an existing functionality that is quite simply evolving over time. It is then quite natural that over time we would develop new versions of that global library, and we would make those new versions also available to other projects within the supply chain. Project B here now in that instance. It was very important for us in the way that we set up this global library approach that we would also deploy what we would call a feedback loop. So think about, for instance, I'll give an example here. Project B develops and implements a cool new feature. It was important for us that we would be able to feedback this know-how back into the library so it could be made available throughout other plants that are using that part of the standardization, where the benefit is clear. Any project could then leverage time and effort spent by a local site by simply reusing what that other site has done, right? I think that's also where the idea of shared cost savings comes into play, that each stakeholder within the ecosystem would be able to benefit from this approach. So now we have, there we go. Yeah. So now we've learned a lot about a couple of topics. We've learned about what RDE is all about. We've learned about what the library is all about that makes those objects available to the respective sites. This slide is really intended to laser focus into those individual objects to understand the content of those and make those a little bit more tangible. So start off with a definition what an object is, first and foremost. So an object is a reusable software module or a design interface that is based on the S88 principle, which would allow objects to be leveraged across multiple equipment or plant types. So overall, we have 3 object types. We have objects for DCS, MES, and enterprise objects. And I'm going to just name a few examples here for each one of those types in order to make them a little bit more tangible here. Starting with the DCS objects, those would on average be used to perform equipment operations. So for instance, temperature control or controlling the agitator or dosing material from one vessel into the next. And anybody who is familiar with S88 will be familiar with terminologies around equipment phase types, equipment module types, and control module types. Then transitioning into MES, there you would find objects that are classically used for operator guidance, or could be used for material identification and consumption, or equipment status updates, or in general, the idea of tracking non-conformances. Because in the end of the day, it is at the MES layer where we are performing the review by exception based release for batch documentation. And then lastly, we have the enterprise objects, and you can think of those objects being interface objects that are used for the northbound communication from a DCS or an MES into any IT-based applications, such as, for instance, LIMS, ERP, document management systems, or even a process historian. And then the last core message here is that an object is not just the software, it is not just the code itself that we have taken into account, but we've also looked at all relevant documentation that is required from a GAM5 V model perspective, because we live or work in a regulated environment in the end of the day, where we've also taken care of documentation on functional specifications, design specification, test plan, test protocols, and so forth as well, because that's, again, where a majority of the time and effort spent is originated in. And with that, we'll hand it back over to Matt, who's going to talk a little bit about what we have achieved thus far.
Yep, thanks, Christian. So this is a slide to give a view of a few use cases within CSL of some recent projects we've had over the past few years. And we redacted specifics around the project name, but just as an example, we're showing some of the reuse examples. And so project one, obviously we can see here where we have some objects that are reused on the order of about 25% and some modified objects. So project one, there was an N-1 project that we fed into this. But we did not, reuse all configuration from pre-project one into here. Project two, we see we have some modified objects and also a bit of an increase in new objects. And this is an example where we have a different process type, different value stream referred to in CSL. And so that created a need to create some new PCS and or MES objects. So we see there that we have a component of reuse that did increase from what we had in project one, but we also had quite a few new objects that were created there. Project three is where we start to see some of the value. So we have a really limited new object declaration, 10%. And I'll say this was, project three was the same value stream as project one. And where we are seeing those new objects is really directly based on equipment differences or process differences that weren't accounted for in project one. We still have a modified configuration, and that's to be expected. I think in this case, we were making some improvements from our initial project, and so we expected a level of modification that would occur there. So as this goes on, our goal is to really reduce the number of modified objects, increase those reused objects, and eventually get to a point where we have minimally no new objects that come out. On the right side is a dashboard. So I think whether you manage your library internally or get some support externally to manage that, it's important to know where you stand from a library perspective, know what differences you have, and just have a baseline for where you sit. So this is a screenshot. I know it's small; it's not intended to be read here, but it gives a view into a view of our library at CSL. So that covers standardization topics. I'm going to move into some of the realized benefits, and we'll talk a little bit about kind of re-summarize where we were in the past, where we feel we're at today, and where we'll continue to go. So the journey is not over, right? There's still quite a bit of work to do to get to tomorrow, and we know that there's a lot of opportunity to improve, and so we're continuing down that journey. So in the past, we had undefined system design. We had some limitations on guardrails, and it did vary regionally based on where the projects were rolled out. We really had different enterprise data transactions that were specific to influence on the regional design, and we had some inconsistent process data availability. We had variations in our historians and variations in the way the data was contextualized in the historian. Today we have established our guardrails for our design, so we have a very clear approach to our standard design, and that design or RDE design can work within different platforms. We have software modules that again, like I said, can be leveraged across platforms and sites and business units. We have enterprise. We have an enterprise process data historian, or we have data historians that are really uniform and have a consistent design to how data is captured across those. We have an unambiguous or consistent design approach for how we integrate with our enterprise systems. And I'll also add that our approach is very much adaptable based on this modular approach, where we can adapt to future technologies in the industry to evolve the system. And for tomorrow, so like I said, we're not finished with what we need to do, right? There's still plenty of work to do within CSL. So we'll continue to work towards our future investments, and I'm adding here that our future investments are going to be focused on risk and priority. So risk based on the landscape of an existing system, or priority based on the business drivers within CSL. We're going to continue to leverage those standardized modules. We really want to minimize functional changes to those. We want to use those to support and reduce costs with future CapEx investment. We will continue to leverage the standard design to more quickly roll out process improvements. So I think that's a really important point, particularly in CSL. If there are process improvements we can make, we want to be able to leverage the consistencies of our system to roll those changes out quickly. And we want to continue to build on our data contextualization, both from a small and I'll call it big data analytics perspective. So that gives a view of the architecture, some topics around standardization, what RDE design and program looks like from CSL. What we're going to do next is hand over to Dashi. She's going to talk a little bit about digital twin, and so digital twin has many definitions. She'll go into that, but we have a specific use case where we had used digital twin for implementation of one of the projects here. So I will let Dashi take it away, and we'll jump into this.
All right. Thanks, Matt. So today I would like to talk about how we utilize digital twin to test and qualify the RDE system at CSL Behring. So first, as Matt mentioned, let's look at what is a digital twin. A digital twin is a virtual copy or a replica of a real-world asset or a physical system. As you can see from the pictures, a digital twin can be anything from a 3D model of a plant, so similar to a Revit model, which would enable you to do a virtual walkthrough of a place, a process model of a production system, which would model the liquid and gases present within pipes and tanks of a production system, along with the ability to model the mass, temperature, and pressure balancing. It could also be a virtual controller, which is an emulated PLC or DCS running in a virtual machine environment. The digital twin system I will be focusing on today will be a recipe-driven process digital twin, which consisted of virtual controllers and a manufacturing process model. So if we move on to the next slide. Okay. Yep. So what are the benefits of having a digital twin? First is virtual commissioning. So one of the main benefits of a digital twin is that it acts as a uniform testing platform. Now, why is this important? Being an automation engineer myself, a typical workflow would involve getting a part of a system to code and then writing some simulation software to test that code. As you may realize, the main flaw in this process is that it's the same person creating the code and then creating the simulation code to test it. So while taking out writing simulation code is a big saving in time in itself, the key benefit in terms of quality is that it enables all parts of a system or a plant to be tested to the same standard, which drives uniformity and standardization across a project. Implementing a standardized test system mitigates also the discrepancies in engineers' approaches to testing different components on the same system. The ability to have virtual controllers and standardized testing environment along with a process model enables testing much earlier in the project as was previously possible. So in the diagram shown in the bottom right-hand corner, shows the value added with the digital twin with being able to shift left, leading to shorter validation and production testing timeframes. Next is process simulation. So process simulation of a plant enables a holistic testing model to show how systems perform while connected to other parts of the plant and see how they affect each other. While the initial value of a digital twin is seen during the delivery and qualification stages of a project, the process model can be repurposed as a qualified model to be used for validation activities once the plant is in production. This leads to provide higher assurance for change control processes to confirm performance of the production system when a change is being implemented. So pretty much ensuring right first time. And all this can be achieved without requiring any further plant shutdowns. So no more downtime to have to test a change. Operator training. Once you have a process model, you can utilize it to train your operators on the system, as well as educate them on how the processes are interconnected. Being able to drive inputs and outputs gives the opportunity to emulate common failure scenarios and allow operators to apply their standard operating procedures without affecting any of the plant's assets. So in the end, by striking the right balance between investment as well as fidelity, as shown in the diagram on the top of the slide there, you could achieve a net positive gain with a digital twin that could optimize operations, drive higher efficiencies, and unlock new opportunities for growth within an organization. So let's move on to how we utilize a digital twin for RDE. Next slide, sorry.
There you go.
Okay, so for RDE at CSL Behring, we created a process model complete with virtual I/O for existing systems. This digital twin was structured to allow for seamless transition to the new RDE system. This meant setting up a library of equipment types, templates, and building process models using standardized components. The intention was to actually set up a digital twin to allow for flexibility. So if it got used on any other side, you could mix and match what templates you needed, depending on what equipment you had, and for it to be somewhat system agnostic, as Matt mentioned previously as well. Virtual I/O cards were created, allowing for simulating of inputs. So we were able to test every single I/O point, verify allocations, ranges for analogs, as well as the sensors, whether they're fail-safe or whatnot for digital inputs. Create device templates to model equipment types present on site. So this is to mimic responses such as starting a pump automatically gave you a running speed and current feedback. And finally, creating an overall process model, which enabled running of a full recipe with realistic flows, pressures, and temperatures within the system. This formed the baseline, qualified baseline project, which was leveraged for testing during the changeover to RDE. So as you can see I don't know whether it's very clear, but in the picture shown on the slide there, we see that you have the automation system graphic. The process logic in the digital twin matched these logic pictures, and they were created using system PNIDs. The components were used to match those present in the DCS system, which help for user familiarity. So if you came in from the automation end, you could pretty much find what you needed on the digital twin without too much complexity. Devices, similar to those in the control system, were given faceplates, so you could monitor the feedback coming from the device in the digital twin, but the added benefit being you could also override it. So you could inhibit that feedback and test your failure scenarios. Then we move on to the actual charts of the CM types. The device templates themselves were given the ability to be set up as many variants as you needed, with the ability to set varying open and close times, different modes, fail open, fail close, and feedback options, whether the limits had feedback or not. Then at the end, we were able to run a recipe within this digital twin, and the ability to do that required little to no interaction from the tester, as it ran seamlessly in the background. There's considerable time saving when you're doing FATs and SATs and not having to change values for you to be able to move over to the next step. So that in itself is a huge time saving. But it also, the tester can still use and interact with the digital twin to inhibit or drive inputs to simulate failure scenarios, but having to do so does not require PLC download. So there's another time saving there. Utilizing this digital twin for testing allowed us to overall optimize our production cutover timeline by leveraging time invested in these testing activities with the digital twin. This strategic approach not only ensured thorough testing of the systems and processes, but also enabled a streamline the transition to production, ultimately reducing system downtime. And I guess with that, I'll hand it back to you, Matt.
Great. Thank you, Dashi.
All right.
Great overview.
No worries.
Yeah. And so the last slide here I'll show, and we'll share this deck as well. But before we go into the questions, I just wanted to say that feel free to reach out to any of us. I think myself and Christian and Dashi are very open to the importance of networking, and I know I see a lot of value in kind of sharing learnings within the industry. So don't hesitate to email myself or reach out on LinkedIn. Same with Christian and Dashi. And within CSL, we have folks all over the globe, so we can hit a few different time zones to build some networking activities. So with that, I'm going to go off the screen share, and we will jump into some questions that Megan is going to walk us through.
All right. Thank you, everyone, for such a fantastic presentation today. Before we get started on the question and answer session, I would like to remind our audience how to submit questions. You can submit questions by typing them in the Q&A box, which can be found directly below the video player. Just for our audience here, for any questions that are not covered today, they will be answered offline. So our first question here for everyone is, what level of minimum automation and integration between S88 and S95 layers is required for a site to adopt the DCS system as a primary batch engine? Does that apply to all types of process equipment in the batch execution, or do you favor certain suites more due to their ease to automate?
There was a few questions in there, Megan. I will take a stab at jumping into that. I think the first question I heard was around the integration with other systems, particularly MES and PCS, relative to the primary DCS engine. And I'll openly say that at the start of my career, before MESs were really relevant in the pharma industry, we had recipe-driven execution within DCS systems, and we had a primary batch engine. So I think this new approach comes out more when we had parallel recipes between MES and DCS, and it's really goal to bring those together and not have separate systems. So yeah, I mean, I think depending on the goals of the business, a good starting point. Well, a primary starting point is around the equipment control and the DCS recipe. And you can look to modularize that a bit to add on other interfacing activities beyond that. But I think you wouldn't want to jump right into interfacing with every system from the start. I think you'd want to focus on the simpler approach of DCS and then see where you can expand. And Christian, Dashi, chime in if you guys have feedback on that question as well.
Sure. Yeah. I mean, integration DCS MES is a philosophical question. I think a lot of it boils back into the requirements around when the operator should be triggered. One of the key advantages is that in the RDE philosophy, we can really guide the operator based on physical events that are happening in the automation layer by means of phase that's been started, right? Or it could be a physical sensor that says, hey, a probe now needs to be taken because of physical event X, Y, right? So if that is a requirement, then we're really talking about a deep connection between the two layers. And then there is the other extreme towards that angle where perhaps the MES kicks off a batch recipe, but the batch recipe is pretty much autonomous, and there's only a couple of events in there for, let's say, sample taking, because we had that example earlier, right? So really the boils back to the business, what the business wants to achieve, like you mentioned that there, right?
All right, great. The next question we have here for everyone is DCS and MES on the same screen for the operator?
Yeah, that's an easy one. So in this case, we do have it on the same screen. So I think some of the traditional MES and DCS system roll out with separate monitors. Our goal here was to bring that interaction of the MES system into the DCS. And so to the best of our ability, we almost don't want the operators to know that they're working with different systems. In an ideal state, an operator would go on the floor, a supervisor, and they wouldn't even necessarily know that an MES system exists, right? They would only know that they're running their batch recipe. So our goal of the design, and I don't, there's still work to get there 100%, but the goal of our design is to really have a singular system look and feel for the folks on the floor, operators, supervisors, quality, right? Because quality is also interacting with the system in this case.
Yeah. I mean, I'd just like to reiterate Matt's point here. It's important. The operator shouldn't really care around which technology it is that he's operating. He shouldn't care if it's DCS or MES or what the functionalities are in the backend. He wants to operate the manufacturing process, and doing that via a singular interface is a key benefit for the plant operator.
Okay, great. Our next question here is, what resources do you recommend for someone learning recipe execution methodology?
I'm thinking, so resources, we think like skill sets, capabilities, or
types.
Okay. Yeah, I think resources could either, my view could either be individual capability or capability of a team, or it could be resources external to what you have available in your internal organization, right? So I think if depending where you are on your own RDE journey, I think any kind of external networking events is a good way to get yourself some exposure into recipe-driven execution or recipe-driven fundamentals. And obviously there's standard industry standard group, or ISA or ISPE that can help to build your network around those resources that you may not have available within your team. I think internally the resources, there's obviously the technical aspect around the systems and somebody's knowledge of DCS systems and MES systems, but it's equally as important around the business process and the process understanding, and particularly if we're transitioning from maybe a traditional paper execution workflow to more of a automated or recipe or workflow engine. I think the rounded skill set of the technology side as well as the business side is important.
Yeah. Just to add on to what you mentioned there, Matt, is very important in any standardization activity to have the process guys on board, because in the end of the day, standardization, a piece of it is the technology, right? But it's really also what we're talking about, the process side of things. Each plant type may do the similar kind of process, but they all do it slightly different, and everybody does it the right way. So having the process expertise, being on board of this journey very early on, is absolutely quintessential. And then, needless to say, DCS, MES experts, it's clear IT experts, but you also want to make sure, particularly looking at a non-conformance tracking and the whole operation of going paperless, that you have the quality people on board as well, because ultimately we'll need their sign-off, right? Yeah.
Okay, great. Our next question here is your OEE monitoring part of your MES system or integrated in that level? And the second part of this question is, does your packaging units connect only to DCS, or do they connect directly to MES as well?
So this is a is a great question, and there's folks on my team that I would love to bring in to help answer this. That could answer this much better than I can. So we'll see if Christian can add to it as well. I think so. Within CSL, we have some examples where we actually don't have MES systems on top of our packaging lines. We have some examples where we have MES more for like serialization purposes, and we generally don't DCS systems that are driving our package unit. So I think where I'll answer this by saying that the secondary kind of packaging activity is a little bit of a different approach than a true recipe-driven execution that we're talking through here. I think specifically where the DCS system is driving those MES interactions, we're looking at more primary manufacturing. But this is a great topic, and I will openly admit that it's not my strongest skill set. So whoever raised this question, feel free to reach out to me on LinkedIn, and I can connect them with some experts on my team in this space. And Christian, go ahead.
Yeah, sure. Good question, right? I mean, I see both approaches being deployed, specifically looking at the secondary side of things. On the one side of that metal, really the industry is more going towards leaner software architectures, where you just want to simply minimize the amount of platforms, as on average, a packaged unit, a secondary equipment will already come with their own local automation on board. Now, however, the question will be, can we trigger events in the MES based on whatever that machine comes on board with from an automation perspective, or is there a need for an automation layer on the top? That's the ultimate question that needs to be answered. I can already tell you that I have seen, or personally been involved in large secondary manufacturing sites where we had a full-blown DCS layer on top of that, because we had so many physical events that needed to be detected that were driving MES events front and back, up to 100 events throughout the runtime of a secondary batch, where it was an absolute necessity. So again, it depends a little bit on the requirements and what type of secondary process we're talking about.
Okay, great, thank you. The next question from our audience here is, can you clarify if the library objects are designed and customized for one customer, or if it's shared with all customers industry-wide?
See, and Matt wouldn't be too happy if that was all across.
I mean, not necessarily, right? I think there's so the library can consist of different levels of objects in a DCS system, right? So you can have a library object for a CM, an EM, a phase, an MES object. Some of those objects may have IP for the company. Some may not. I think in this particular case, we were really speaking to a CSL library with our platforms that we have, and there might, I'll let Christian answer if there might be some of the lower level objects that are shared as within the Siemens platform as an example. But I would say, in general, I think the industry needs to be open to sharing library process control functionality that is not IP. And I mean, I don't have a visceral reaction to, sharing library objects unless there's an IP aspect to what we have. So, and then, Christian can comment on how, configuration may be shared with other customers.
Yeah, so on average, I would say that a functionality that is very hardware centric is much easier to be standardized across multiple different end users out there, because a binary valve is a binary valve and a motor is a motor, right? And all vendors out there from a DCS perspective, or many will have libraries available that also adhere to the pharma requirements that we have. The more northbound we go, the more process we are talking about, the harder it really becomes to find the one common ground. So if you are, in the end of the day, on the MES level, it is very difficult to align visual inspection across all of pharma manufacturing out there, right? But there's this common ground in between, particularly on the DCS layer, where also we as Siemens, we are looking at developing templates for libraries that can be used across the life cycle, because the dosing function at the end of the day will only differ in the amount of, let's say, valves and motors to be used, but not in its core functionality, really, right? So it's certainly something that we're looking at, right?
All right, fantastic. Well, with that, we will wrap up today's event. I want to thank our audience for attending and for participating in today's event, and our wonderful speakers for such a great job today. As a reminder to our audience, any questions not answered during this session will be answered offline by our speakers. I would also like to thank our sponsor, Siemens Digital Industries, for making today's educational webcast possible. We would like to ask everyone in the audience to participate in a brief survey. This survey will appear on your screen after today's presentation has ended. You'll receive an email alerting you when this webcast will be available for replay, and we invite you to forward that announcement to your colleagues who may have missed today's live event. Thank you to everyone for joining, and we'll see you next time. Have a great rest of your day.
Thank you for watching. To learn more about this topic, check out the links in the description. And if you enjoyed what you saw, like the video and subscribe to the channel.